Hi Trigoners, so today we are going to start with day 3 of our notes on statistics, and here are our objectives. We're going to be able to understand the z-score, be able to find a z-score, be able to use a z-score to find the probability that a randomly selected data point is a specified distance from the mean. Okay, so right now we don't even know what a z-score is. That's all right, we're going to figure that out right now. Let's take a look at the problem that we did yesterday. So let's revisit that. So yesterday we talked about the houseflies and their wing lengths. So go ahead and reread the housefly problem and go ahead and fill in some numbers on the normal distribution there. Great. Okay, so yesterday we talked about how if the mean was 4.6 and the standard deviation was 0.4, that you could look at a normal distribution. Okay, so what that means is that we have what percent of flies have wing lengths between 4.6 and 5.4? Well, here's 4.6 and here's 5.4. So yesterday we said, well, that's 34% plus 13.5%. So the probability that a randomly selected data point value would be in this particular interval would be 47.5%. But here's the problem. Question B asks the percent of flies that have wing lengths less than 4.1. Well, 4.1 is right here. We don't have information using the 689599.7 rule for that one. So what we're going to have to do is use a z-score. So a z-score is a numerical measurement of how many standard deviations a data point is below or above the mean. So for example, looking here, if you're right at the mean, that is a z-score of 0. If you're 1 standard deviation from the mean, that's a z-score of 1. 2 standard deviations away is a z-score of 2. Here z equals 3. Again, if you're 1 in the to the left of the mean or below the mean, that z equals -1. We have z equals -2 and z equals -3 for 3 standard deviations from the mean. So how do we find a z-score? Well, our z-score is our data value, our data point, minus the average divided by the standard deviation. So x is our data, m is our mean, and then we have our standard deviation. So for example, if our data is 4.1, you would say our z-score is 4.1 minus 4.6 divided by 0.4. So our z-score is -1.25. So that actually makes sense because right about here would be -1.25. Okay, so now we have to figure out how to use a z-table. Well, I went ahead and gave everyone a z-table. It's in the module for the statistics. So go ahead and grab that right now, and we will talk about how to use that. Okay, so here's our z-table. Notice we had 2 pages. Here are our z-values right here, and notice one of the tables, one page, had negative z-values. The negative z-values would be for the z-values to the left of the mean, right? And then the other table had z-values that were positive z-values. So since our z-value for this example was -1.25, the first thing you do is you look on the z-table for -1.2. And then I wanted it to be -1.25, so that would be right here. So there we go. This is our probability associated with -1.25 on the z-table. And notice over here, they're trying to give you a little hint. That gives you the area under this standard normal curve, and it's always to the left. So if this is z equals -1.25, this is the area that they're giving you, 0.1056, or approximately 10.56%. Okay, so let's go back to our example. So if they're telling you that 10.56% of flies have a wingspan less than 4.1. So this area under the curve, if the z-score is 4.1, would be 10.56%. Okay, let's do some more examples. Okay, making sense of the z-score. So again, if you look at the table, they told you the cumulative area was the area to the left of the z-score. So we know all probabilities add to 1. So in order to find the area to the right of the z-score, what would we do? Well, for example, let's say that this z-score was 1.5. And again, let's practice looking at the table. So this time I'm going to go to the table. There we go. And look for positive 1.5. So again, here's the z-score. Again, they're telling you that the area to the left is what's given. So go to 1.5, and there's 1.5, 0. So they're saying that the area to the left of a z-score of 1.5, the area under the standard normal curve, that would be 0.9332. Okay, so they're saying that if this is z equals 1.5, right about here, this area is 0.9332. Now, okay, if I wanted to find the area to the left then, couldn't you say sorry, to the left is 0.9332. So if I wanted to find the area to the right, you would do 1 minus 0.9332, which is 0.0668. So that means that this area is 0.0668. That would be to the right. Okay, what if I want to find an area between two z-scores? Okay, so for example, let's say this is z equals 1.5 and this is z equals negative 1.5. Well, we already found that value on the z-table, that to the left of a z-score, the area under the curve, was 0.9332. And so we realized that this area over here was 0.0668. Let's just check that out on the z-table, though. What would happen if I looked up negative 1.5? Let's see what would happen. So if I go to my z-table, there we go. And this time I wanted to find the area under the standard normal curve for a z-value of negative 1.5. So again, here's my negative 1.5, here's my 0. So again, 0.0668. No surprise, right? So over here, we know that this area would be 0.0668. So again, if you were looking for the area in between, under the curve, in between those two z-values, right, you could say 0.9332 minus 0.0668. 0.9332 minus 0.0668. And so you should get an answer of 0.8664. Okay, let's go ahead and do some examples with the z-table. Okay, so first of all, what I would like to do is I would like to test the z-table. What if I picked a z-value of 1? So go ahead and pause the video, choose that z-value of 1, and see what they tell you is the area under the standard normal curve for the z-value of 1. That again, we would want always the area to the left of that z-value. Okay, so notice if z is 1, which we're actually 1 standard deviation from the mean, it's 0.8413. There we go. So that means that the area under the curve is 84.13%. Now going back to our 68, 95, 99.7 rule, there you go, if z is 1. If you add up the percentages in these regions, you would end up with 34 plus 34 plus 13.5 plus 2.35 plus 0.15%. So you end up with you end up with 84%. So if we go back here, we realize that that table gave us 84.13%. So again, there's a little bit of rounding going on, and again, this is not going to be exactly the same, but that's pretty darn close, 84.13, 84%. Okay, so go ahead and take a look at example 1, and we're going to practice using the z-table. So go ahead and see if you could do A through D. Got it. Okay, so again, if you want the area under the curve, there you go. There we go. We ended up with 50%. Over here, 50%. Okay, so again, what we're trying to find right here, if I said the z-score is 1.42, we're trying to find the probability that if you picked a data point at random, that data point would be less than 1.42 standard deviations from the mean. So that's what we're trying to find. So if you go to the z-table, and again, you're looking at 1.42, we could practice. There we go. So 1.42 would be right here. So that's 0.922. And that's why we have, there we go, a 92.22% chance that if you pick a data point at random, that it will be less than 1.42 standard deviations from the mean. What about part D? We had a standard, a z-score of negative 2.34. So here we go. Negative 2.3, negative 2.34, that would be right here. So here is my z-score of negative 2.34, and that was a 0.0096. So that is why if I probability that you pick a data point at random, that it's less than negative 2.34 standard deviations from the mean under the standard normal curve. So we ended up with 0.0096. So go ahead and pause the video again and go ahead and try E through, oh, there were a lot of E's. So E, A, B, C, D, E, that's F. We'll just leave it the way it is. Go ahead, it's okay. Go ahead and find the last 4 answers. All right, everyone, let's see how you did. So first of all, we have a z-score for the first part E here of 2.6. So if you look at your table, the value associated with z equals 2.6 was 0.9953. So if we go ahead and do 1 minus 0.9953, because 100% of the data falls under the curve, you end up 0.0047. So let's think about what that means. That means if you choose a data point at random, there is a, let's see, that is a very small chance, a 0.47% chance that your data will be to the right or more than 2.6 standard deviations from the mean. Okay, let's check out part F here. I went ahead and renamed these. We want to know what is the probability that a randomly selected data point is between negative 1.56 and 1.3 standard deviations from the mean. So again, if you go ahead and use your z-table, if you want to find the value associated with a z-score of 1.3, you get 0.9032, and the value associated with a z-score of negative 1.56, you get 0.0549. So go ahead and find the answer. There are a few ways you could do it. You could do 0.9032 minus 0.0549 and end up with an answer of 0.8438. What about part G? So G, it's the absolute value. So that means that Z is greater than negative 2.2, but less than 2.2. So you end up with, let's see, a z-score of negative 2.2 is 0.0139, and 2.2 is 0.9861. So pause the video. All right, so finishing up here for part G, then you could say 0.9861 minus 0.0139. And lastly, for part H, it says absolute value greater than, so absolute value greater than would be z greater than 2.2 or z less than negative 2.2. So here is your answer. Have a great day, everybody.